Hello, everybody. My name is Alex Watts. I'm the co-founder and CEO of Fastlane, which is building a holistic liquid staking token and MEV infrastructure on the Monad blockchain. And what a week. I am extremely tired. Playing around on Testnet has been an absolute blast, but there have been some learnings. There have been some things that might have been a little bit suboptimal when it comes to different app implementations. The good news is that this is all solvable. And in fact, we've actually got a lot of solutions that are already available right now for everybody. This is a very short video. And in this video, what I'm going to do is I'm going to cover what some of these hiccups might have been for different apps as they were rolling out on Testnet, as well as go into a little bit about how these solutions that we've got can help apps deliver the best UX for their users so that their users can really experience Monad, the blockchain, as it's meant to be experienced, which is blazing fast. The very first thing that really came about with the Monad blockchain is this whole concept of asynchronous execution. And async execution actually led to quite a few just like very subtle differences in between how the blockchains work on Ethereum and how blockchains work on Monad. And so we're going to cover the two key intersections here, which is the way gas is handled, and we're also going to cover how this might have some impact on our PCs. First, when it comes to the way gas works, just as a refresher, on Ethereum, the gas is charged based off of the gas cost, which is the gas price times the gas used. It's a little bit overly simplistic. You might be thinking, what about the base fee? What about the priority fee? And if you're really technical, what about the max fee per gas and max priority fee per gas? But just for the point of moving this forward quickly, let's just assume it's gas price times the amount of gas you actually used. However, on Monad, we have asynchronous execution. This is a huge advantage. It's a huge unlock. It interleaves consensus and block building with actually executing the block and actually generating that state. It's one of the main reasons why Monad is able to be so fast. But there's a few problems with interleaving execution with consensus, such as if we don't actually execute a block, how do we know how much gas a transaction actually uses inside of that block in order to make sure that there's room for it? How do we prevent double spend? How do we make sure that a transaction is actually able to pay the gas cost ahead of time? How do we mitigate free data availability, which is just a way of saying information gets posted without actually paying for it? And how do we prevent empty blocks, which is very bad, not just in terms of the throughput, but also in terms of validators trying to maximize their revenue so as to keep the network really decentralized and focused on like a full distributed blockchain. Another problem, how do we prevent and mitigate spam? If we're not able to identify transactions that aren't really paying their fair share, then all of a sudden we have this huge problem where people can just spam transactions to the blockchain. These P2P networks can propagate these transactions all the way to the leader using up valuable bandwidth and using up valuable network resources, but they're not actually legitimate, right? Because we have no way, because of asynchronous execution, to actually see that they're legitimate until after the fact. And so at the end of the day, we've got this pretty serious problem. And the way that the Monad blockchain actually handles this problem is by charging based off of the gas limit rather than the gas used during execution. This is a very important breakthrough. So on Ethereum, let's say you've got 3 transactions you're building a block. There's transaction 1, there's transaction 2, there's transaction 3. These lines represent the gas limit. And now in blue, we've got the gas used. So the first transaction might use, let's say 2/3. But then inside of this block, we're just going to start off where we left off. And the second transaction might use this much. Third transaction might use this much. And we've still got all this space for more transactions. Monad's a little bit different. On Monad, because we're building this block without actually knowing how much gas is being used, we have to build the block based off of the gas limit. So let's build the same block with 3 transactions. And when we start trying to execute this execution happens like an entirely another block later. Yeah, you can be really close to the validator and do this really quickly, which is one of the things that Fastlane will do for people that are connected to the Fastlane network. But here's the thing. as we are building this block, let's say this first transaction only uses a portion of its gas. It doesn't really matter. Like, we're not going to use the rest of it. We're still going to pay off of this full gas limit. And so you can see how we've got these like gaps inside of the block, which is where the gas used doesn't quite approach the gas limit for each of these transactions. So paying for this unused gas, like having to pay this difference here, like having to pay for that is one of the like ways that Monad is able to stay robust, stay decentralized, stay permissionless, while still staying like extremely fast, like orders of magnitude faster than legacy L1s, let's call them. This also does disrupt a few other things, though. One of the main things that we found it disrupted was account abstraction, such as ERC or EIP 4337. And the reason why this is disrupted is because 4337, if you look at the actual contracts, what they do is they will look and see how much gas someone used. And when they are reimbursing the person that was sponsoring this gas for the actual user, in order to have like a good one-click UX using gas abstraction, when they are reimbursing this user, they look at the gas used. But the gas used is not the cost. And so what we had is this scenario where, like, a day before testnet, all of a sudden, all of these 4337 bundlers were just hemorrhaging money. And it's because they were only getting reimbursed for the gas used, but they were having to pay the full amount. And that was a problem. Good news is that it was a foreseeable problem, and so Fastlane had a solution ready to go. We have actually built a asynchronous paymaster into our liquid staking token. This is already available live. If you are an app that is using account abstraction or using something that is 4337 or similar in order to deliver a one-click, like smooth, bespoke user experience for your users, and you want a system that is already built around the changes that Monad has in order to like maximize your just overall flow and maximize your overall just user's experience, we've got it ready to go for you. The way we handle this is actually by using a very elaborate system for escrows. And one of the things that I think is really interesting is that this escrow system is actually used in a very similar way by the Monad consensus protocol itself. This is how they mitigate double spend at the protocol layer. This is the reserve balance or the carriage balance or the carriage cost, whatever you want to call it. What we've done is we've taken that logic and we've put it on chain. We've put it inside of our liquid staking token so that you guys can deliver a like permissionless, trustless one-click UX. However, there is another problem. If you are an efficiency maxi, you might have realized that like we've got all these like unused chunks, right? Like it's sitting there. It's gas that's been paid for. What are we going to do with it? Like someone has paid for this gas. You know, we don't want to pay too much. We don't want to overpay. We also don't want to have these blocks that are like not fully packed. And so this is it's a tricky problem. And so what we have done at Fastlane is we've decided to approach this through a just overall a focus on having a task scheduler or a task manager. And the overall idea is that the MEV layer is, at the end of the day, very similar to the operating system. It's very focused on trying to maximize efficiency and making blocks as valuable as possible. And that means filling in these empty gaps. And so what we've done is we've created this system where apps that are in need of automation services, think like dollar cost averaging, if you want to do the same thing multiple times on into the future. Or maybe you're a central mode order book and you need to turn the crank in order to keep your prices up to date or in order to keep your margins balanced. Maybe you just want to do like a dead man switch or something like that. Maybe you want to automate payment to somebody. Maybe you want to, in some way or another, do something that's automatic that you know is going to happen in a provable, on-chain, trustless, decentralized way. And you don't want to run any infrastructure. And you don't want to have users sign 1 billion transactions that you just like store in the cloud somewhere in a trusted permission way. That's what the task manager is. The task manager is designed to allow people to queue up tasks that'll execute in the unused portion of the gas that's already been paid for by people. In the future, this will actually be mostly sponsored by searchers, by bots. And this is where partnerships from validators such as Coinbase and Figment is going to be so crucial, because these validators and the MEV infrastructure that they are running is going to be what really helps us make sure that these unfilled gas allocations get allocated to handling all of these tasks that are automation requests. And so now apps can just not run a bunch of backend infrastructure. You don't have to run a keeper network anymore. And this is pretty cool. This is already live. It's already also built into our liquid staking token. You can see the onboarding documents on our website. And it's just another one of the solutions that we're building that is a very, in our view, very interesting solution to a very Monad specific problem. And it's the kind of thing that you can only do on Monad. And when you combine this with Monad speed, it's like all of a sudden now you've got these persistent like programs or tasks that are just running on chain. And it's this entire new paradigm. You don't have to just have a keeper network or a bot that's just running to update your app anymore. And we think that's pretty cool. Because the MEV infrastructure has not been rolled out yet, right now we are just automating this ourselves by just spamming the crank for our task manager. It is already load balanced, and we do have a few rules, such as a task cannot create more than one task. It's just general task scheduling logic, but please check it out. And if you have any questions, we're here to answer. We will be submitting some task manager use cases to the Monad Hackathon at ETH Denver. The next thing I want to talk about is RPCs. If you have been using Monad in any capacity over the last week, you've probably run into some RPC issues. The RPCs have been the main bottleneck for the Monad Testnet experience so far. And the reason why this is unfortunate is because an RPC is really the lens through which people experience the blockchain. If the RPC is slow, people are going to think the blockchain is slow. Similarly, if the RPC is down, people are going to think that the app is down. And this is not true. The RPCs are this critical dependency that apps and users have for the blockchain. And from their point of view, they can't really tell the difference, right? It's in the liveness path. If you want a high data availability blockchain, you have to have high data availability RPCs. So our takeaway from this at Fastlane is that Monad is actually way faster than people think it is. And so we're very, very bullish on that. But this does also have an intersection with asynchronous execution that we wanted to shine a light on. With asynchronous execution, what's happening is that these validators are actually sending, let's say they mine block N or they create block N. They send it out to the RPC nodes. And then after the RPC node receives it, then it executes it. And it becomes an RPC that now has the block in state. And so if we combine this with what these application backends are doing, we've got the validator sending out to the RPC. The RPC is then executing the block. Meanwhile, the user, through their front end, is sending a request for data to the app backend. The app backend is then over the network sending a request to the RPC. And so you've just got a lot of load coming together at these critical points. What we have observed at Fastlane is that it's actually not the nodes that are the bottleneck. It's not the RPCs themselves. It's the ingress points. It's the networking stack. And for us, in our case, it was the anti-DDoS protections are actually the bottleneck, and we are working on optimizing that right now. That being said, bottleneck is pretty good. In the future, ideally, I think what most apps would like to have is a scenario where they actually co-locate their own node or their own RPC with their backend. That way you don't have to have this network request in between the app's backend and the RPC, in which case you don't have to worry anymore about an entire two network hops, one from the backend to the RPC, another one from the RPC to the back. You also don't have to worry as much about overloading. You don't have to worry about caching state or anything like that. The entire thing gets a little bit smoother, and the data flow to the app backend itself is now limited to just the actual block, right? And so you're putting much less strain on the network that way. And so this is the future. Fastlane is going to be working with validators. We're going to be able to connect you guys to the validators through our relay. There is going to be a lot of security and safety because bandwidth isn't infinite. These are all limited resources. That's kind of the whole point of like crypto economics. And so it's all going to be incentive compatible, but we also want it to be fast. Unfortunately, this is not yet live. It's because the node code is not yet public for any team. And more importantly, with the Monad network, P2P connections are not yet gossiped or otherwise discoverable. And so if you want to run a full node, everything has to be like directly hard coded in. You have to be working with validators. And by the way, thank you to the validators who have actually added our full nodes downstream of their own validators. But there are still optimizations we can make. So again, the current system is user front ends calls at backends then call an RPC. These are both network hops. Meanwhile, the RPC is also getting sent the updated blocks from the validator, and it's also updating, executing these blocks in order to figure out the most recent state so it can respond to the app backends requests. It's a lot of network traffic. And so one of the things that we are very interested in doing is separating reads from writes. With blockchains, by the way, a write is just a transaction that updates the state. Reads, or view calls as some people might refer to them as, are just reads. It's things like getting balances, getting exchange rates, getting how much an option costs, getting what type of Kuru NFT monster you have. These are reads. And so one of the things that we're interested in doing in the future is having a load balanced way of handling like writes, because that's relatively easy to do from a network standpoint. You can just verify a signature. This is how you prevent double spend, etc. But if we are downstream from the validator, we don't always have the most recent information because of asynchronous execution. So it's hard for us to necessarily know at any given point in time that a user has the balance that they say they have when they send a transaction. Because what if on one hand, the validator is sending us the block and we haven't finished executing it, and then we get a user request on the other hand? It's very hard to run into, and it's very easy, I should say, to run into a distributed systems problem where your reads and writes are not strongly consistent, at least if you're not the validator. And the reason why Fastlane is working so closely with validators is because validators really are uniquely positioned to be able to do this. They're the only entity that can deterministically know that when it is putting a transaction into its block, that due to the Monad BFT and the Monad consensus spec, that it is not a double spend. The rest of the network can be confident, but not 100% sure. The good news is that we'll have a solution for this too. Escrows and things like staking and restaking, which is how our solution's probably going to work. It's the alpha. This is all going to play a pretty key role in it going forwards. In the meantime, reads can be batched together with a batch getter. It's a very easy way to mitigate the number of network requests that each app backend is making to a RPC. These app backends can batch multiple of these requests together. You can even batch different users' requests, such as every 100 milliseconds, every new user that's popped in, you just batch them all together. Monad blocks are very big, and so you can do very, very big batches, which is very bullish. It's actually one of the things we're most excited about is the batch size. And so at the end of the day, like, there are a lot of like optimizations and a lot of strategies that we can use. The batch getters are very, very simple. Like, if you wanted to do it, it would just be something like you could literally do it in like 2 seconds. Get balances, address, user, address, call data tokens, external returns, all right, balances. And so you would just take, so this would be just like a batch getter in order to get a user's balances for multiple different tokens. And the way it would work is, first of all, you'd have to make the array. And then you would just do a for loop for token, whoops, for 6i, listen, token length, plus, tokens I dot balance of user. And like that would be it. It would just be that simple. And so obviously do your imports and stuff, but like something like this would really help a lot. And so then your backend, your RPC would call the batch getter, and you would be able to have one network request. You could even have an array of users that you do this for. You'd have a nested for loop. The one thing you have to be careful of is that you don't want to run out of gas, right? So make sure that you're staying inside of the block gas limit. Otherwise, the RPC is going to reject the call for too much gas. You might think, but view calls don't use gas. Well, the nodes still very much care how much gas you use, even though it's a view call. The other thing is that, this is something that Fastlane also wants to really help out with. We've got a load balanced, globally distributed RPC network that's ready. This is meant just for reads. We will have a different take on the writes because they deserve a different type of approach in order to be like maximally fast and maximally just aligned with the Monad ecosystem. But for these reads, especially for app backends, we're ready to go. And this is something where we've actually got a lot of experience. Fastlane's been around for coming up on our third anniversary, or our second anniversary, our third year. Very excited to have this network up. Many of you guys have already worked with us before, so I'm not telling you anything new. But this is something that we thought that we could help out the most by offering this service to different apps. This is not going to be something that's available to users or wallets. Again, the DDoS protections and the mitigations and the optimizations are a little bit different for that type of user base. But in the meantime, if you are an app and you've been having issues with RPCs, we're here to help. So hit us up. Yeah, I really appreciate the time, and thank you for watching. And I will see you guys on Testnet, and also buy my fantasy top. Please buy my fantasy top. Also, don't forget to stake your Mon with Shmonad. We are currently the only liquid staking token that actually has yield, largely because a portion of the revenue generated by the paymaster is actually being funneled back into the liquid staking token. Same with the task manager. Both of these have pieces of their revenue going to amplify the yield there. And this is the exact kind of holistic approach that we mean when we say that Shmonad is a holistic liquid staking token. This is also one of the reasons why so many validators have decided to work with us in delivering a solution that helps them really keep the network as decentralized and safe and live as possible. So yeah, thank you for watching.